Modeling entities as semantic points for visual information extraction in the wild. Paper ID is WebPM286. Recently, visual information extraction has gained increasing importance in both the academic and industry. However, current benchmarks for VIE are relatively simplistic and do not fully represent scenarios with real-world complexity. In light of this, our first contribution is the curation and release of a new dataset called SIBR for VIE. Document images in this dataset are much more challenging, as they are taken from real-world applications and contain common difficulties such as blur, partial occlusion, and printing shift. Our second contribution is an approach called ESP, which models entities as semantic points and could greatly benefit entity labeling and linking. For instance, center points of entities are enriched with semantic information that describes the attributes and relationships of different entities. The existing dataset primarily consists of document data with clean backgrounds and well-organized text. Here we present several samples of S or OIE, FUNSD and XFUND dataset. Due to the decent OCR results obtained by OCR engine, thereby giving rise to language model-based methods such as layout LM. But text and visually rich images taken from real application are hard to detect and recognize, which will reduce accuracy significantly for the language-based model. The layout LM sequence method has become a mainstream approach for VIE task, but there are four common problems. First, all these methods rely on OCR engine, which would lead to an error delivery. Second, language-based model can't adapt to new language, which not appear in training set. Third, due to layout information missing, model need complex operation to capture it. Last, all this method will limit the token number to a certain value. So, can the above issues be resolved if we design a model that takes the entire image as input, does not require a pre-existing OCR engine, recognizes entities directly rather than characters, and introduces semantics through pre-training? To solve above problem, we firstly present the SIBR dataset, which difficulties such as blur, partial occlusion, and printing shift are quite common. We can see that SIBR has a rich background color from the color distribution comparison figure, and has a lots of overlap bounding box compared with other datasets from the table. All of these would require the model to take into account the bottom OCR problem. Then, we present the ESP model for VIE in the wild. First, a convex tiny FP in backbone is used to extract image features. Fed with 3 convolutional layers appended to the convex, EAP module generates 3 kinds of outputs, detections, text contents, and 3 center-based features F1, F2, and F3. The text recognition task is optional, which ESP does not rely on it. At last, F1, F2, and F3 are input to 3 pre-training tasks. EITM aligns F1 with text embeddings given by BERT by a contrastive learning strategy, which is designed to provide semantic feature for entity extraction and entity linking task. In the final decoding stage, entity extraction module takes concatenated features of F1 and F2 as input and predicts categories of the corresponding entities. The process of entity linking is the same as entity extraction. Entity linking module takes concatenated features of F1, F3 then adds position embedding, and class embedding as input and predicts entity relationships. Finally, the EAP module output, the box, text content, the entity extraction module output text classification, and the entity linking module output link information. We don't need EITM module in inference stage. Pseudo labels are used in pre-training stage. Based on the OCR results extracted by OCR engine, we can generate pseudo labels with just a few simple steps. First, generating key library by counting the occurrences of text contents. Second, the key value pairs are generated based on the spatial relationship. Text appears in the key library will be considered as a key, then values will appear below or right of the keys. We perform extensive experiments on FUNSD, XFUND, and CHORD and TAB. 1. ESP outperforms all existing methods on the entity linking task by a large margin. This proves that visual and geometric features can largely benefit entity linking prediction. On the entity extraction task, ESP also achieves competitive performance, with only 50 million parameters and 0.9 million training data. We argue that fine-grained visual cues, such as fonts, colors, positions and typographic information, are crucial for VIE. We compare ESP with three multi-language approaches. We pre-train ESP on English datasets, but fine-tune and test it on other 7 languages. Note that the EITM task is not trained in the fine-tuning stage, meaning that the model does not perceive the other 7 kinds of languages. Results in tab 2 demonstrate the effectiveness of visual information, in which ESP can surpass multi-language models only depending on visual cues. Experiments are conducted on funds to illustrate the impact of various combinations of the pre-training tasks, and the results are concluded in tab 3. By comparing A with each of B to E, we find that every pre-training task benefits the proposed ESP. Specifically, C and E indicate that entity extraction and entity linking pre-training tasks benefit corresponding downstream tasks most, resulting in an increase of 2.52% and 27.69%, respectively. D shows that the EITM module indeed learns effective vision language representation and improves entity extraction and entity linking by 2.45% and 0.45%. By comparing F with G and A, we find that the benefits of pre-training tasks far exceed pre-trained data, 6.02% versus 0.06%. We also experimentally prove that the last 3 semantic pre-training tasks can boost entity detection. By comparing F and A, we find that the addition of EITM, entity extraction, and entity linking tasks can improve the accuracy of detection by 4.35%. It demonstrates that the detection and semantic tasks can be mutually reinforced. As revealed in Table 4, ESP achieves SOTA performance on SIBR. However, what's interesting is that the current algorithms are not sufficiently effective if considering the bottom OCR problems even for ESP. Taking the detection and recognition results into consideration, all methods' accuracy decrease by a significant margin. VIE in the wild still has a long way to go. Thanks very much.